Welcome everyone back to my video series on how I personally would approach a maze challenge, and this is mainly designed for my students, but I want to give them just a glimpse into how I would approach things. And on the last one, we used some math to have it drive exactly 17 inches forward, and it worked like a charm. I hope today will be just as successful. One of the things here is we see that there's a gyro sensor involved, and I want to show you what the robot looks like. So if you take a look at the robot right now, you will see that is the gyroscopic sensor. A couple things you need to know about this is that when you turn on the robot, you don't want to be moving this around. You want to put it on a flat surface, turn it on, and then we're going to reset that gyro, let it wait a little bit. And the reason why is if it's moving when it gets calibrated, when you turn it on, it's going to always think that's normal, and it's going to mess everything up. So you begin by having that there set up. Another little feature I've added is this touch sensor. And the reason why I'm adding the touch sensor is, one, it gives me an opportunity to talk about another sensor. Two, we're going to talk a little bit about loops and some Boolean conditions. And three, when you press this button, you have to press kind of hard and let go, and it's real easy to like accidentally move it. And if you think about it, if you were to do that complex maze and at this angle, and then you were to do it again, turned like 1 degree, that's going to mess everything up. So you don't want to accidentally bump it when you do it. If you press this sensor, it's a lot easier to press it and have it go. You can also attach a little bar there that makes it even easier to press. So that's the whole goal there, is to add that sensor. So we're going to go ahead and code this. We're going to start with the easy one. We're going to do the push sensor first, and then we'll go look at the gyroscope sensor, and then we're going to look at what this code will look like using standard robot C, not the graphical. So stay tuned. Here we go. First thing I want to do is make sure my motor and sensor setup is correct. You'll notice sensor is touch sensor is sensor 1, gyro sensor, sensor 2. You'll notice I have these set up and it didn't affect the program, but we do want to make sure these sensors are set up right. And let's just go ahead and make sure on the touch sensor it's the EV3. Sensor mode, you have touch or bump. Touch tells you if it's being pressed or not. Bump counts each time you press it. I believe that's how it is. So here we go. Actually, I want to show you one more thing. When I built the robot, I wanted to make sure these cables are nowhere near the wheels. So you'll see that there's nothing kind of near a wheel. Even that touch sensor cable, which gets a little bit close to it, we feed it through the middle here on the back, and we're doing that so that we keep these out of the way. And it might make it a little awkward at times when you're pulling this out and putting it back on. But once it's running, you will be happy to have those cords sort of out of the way and not getting caught up with the wheels. It's a very important step. So I'm back here at this picture because I want to show you, before you begin programming, one of the things I highly recommend you do is go into the Robot C menu here and go into what's called port view so you can see the values you're getting on the different sensors. So that's going to be an important step. So I've got this loaded up just for you, but it's a little bit fuzzy. So I'm going to bring this camera down a little bit, try to show you just a little bit better this port view. And so what you want to do is you want to cycle through. You go to the right 2 times. You see how it kind of follows that tab. That top selection is port view. You just click it. And then right away, you can see touch. Right now, the value is 0. And when I press it, it's 1. So 0 or 1, that's the only thing you have on the touch sensor. Now we're going to go to the right one. And sorry, I got to press it a little harder. And now you notice it says -8 degrees. I bumped it, -12, 10. So you want to just see how that works. So notice we are going up in numbers as I'm turning this to the right. And then we're going down in numbers as I turn to the left. So it's a really important thing. And if I get it to 0, so I should get right to 0. That 0, well, anyways, that 0 represents when it first started. That was the angle it was at when I turned it on. So do keep that in mind. You can reset the value of it and it'll put it back to 0. So just FYI, it's important to know that that's a good thing. All right, so now we're going to take that and put it to practice. The first thing we want to do is we want to wait until we press the touch sensor. So we're going to scroll down here. We're looking for the touch sensor. Motor commands, EV3 LED touch sensor. Okay. So we're going to drag this over, and we're going to, actually, let's do something first. What we really want to do is, I'll put it as a comment. So I added the comment. This is going to be after we reset the gyro. So we're going to reset the gyro wait, and it says don't run until the touch sensor is pressed. And so another way of viewing it is wait until the touch sensor is pressed. Okay, and so what we can do here is wait until. Bam. I'm going to drag that down one. Wait, sorry, there you go. Wait until, and its touch sensor is get touched value equal to false. Wait until it's equal to true. That was also 1. So true and 1 mean the same thing. And so it's up to you. I actually like to work off of true. Wait until touch sensor is equal to true or equal to 1. Either way, that's how we do it. So this is going to basically not do anything until we press it. Okay, so we're going to go ahead and test that out and see if that works. Okay, so actually my computer is wonky, so I'm actually using a different computer that I'm going to go ahead and just want to remind you. What you want to do is click compile, make sure there's no errors. We're going to click download the robot. As long as that's there, we can press start and continue. So let's go ahead. We got it uploaded. I'm going to go ahead and stop that, bring it over, and let's take a look and see if it works. Okay, here we are. There's the brick. It's right on my little table right by the keyboard. I'm going to go ahead and start it. I have to start it here, and it should just wait. See, that's doing a little beepy beepy. It's waiting, because now it's waiting for me to press that. As soon as I press it, it drives off. Notice, drove. We're good. So, bump sensor works. Let's work on the next one. Okay, before I go any further, I wanted to do a little research. This is how I go about it. I know there's a gyro. I know kind of what it does. I want to find some good documentation. So I'm actually going to ev3lessons.com. Thank you so much for putting this out there. All right, so we're going to take a look here and notice a couple things. It's helpful to note that there are 2 common problems using the gyro. That's drift and lag. So we're going to learn what this is and how we can kind of do it to calibrate. So very important that you follow some of that. A couple things about the gyro sensor. As you can see on here, it detects rotation. So it measures the rate of rotation in degrees per second. Also just shows you where the total rotational angle is. In other words, you can let it determine how far you turn. Now, here's the problem. The accuracy of the sensor is plus or minus 3 degrees for a 90-degree turn. Okay, so that is definitely significant, and that's one of the things we have to take into consideration. We're going to want to reverse the order of these two. Let's wait until it's pressed, then reset the gyro as one way of doing it. That way, pressing the button won't bump it a little bit. That might make it a little easier. Although if you bump it, you're in trouble anyway. So a couple things. So I'm going to go ahead and drag this up. I'm going to do that, and then everything else is good. Okay, so what we're going to do is we're going to use the gyro to turn right, and I showed you that it starts with 0. Resetting the gyro and waiting is what you want to do to get it going. I moved that to be after we wait until the touch sensor is pressed because I didn't want to have me turning it on affect the movement when it reset the gyro. So I'm going to do that touch sensor. And I'm thinking of even just copying that weight and paste it in here and just drag it down. So even after I touch it, it's going to wait just a little bit. And I don't even need it that much. I'm going to put 200 milliseconds is what I'm going to do. And so I don't want it to wait a lot, but at least that should be enough. I'm going to make that 400. Should be enough to let it settle down before, after I pressed it, just in case I'm a little harsh or I bump it or whatever. So now we want to turn right 90 degrees. And one of the things about the gyro is it's plus or minus 3 degrees. So what I'm going to do is I'm going to turn right, but I'm going to do it, I'm going to keep turning to the right a little bit at a time until I get to 90 degrees. So I want to go down to the sensor where it has the gyro sensor. And there's the, we don't want to do it that way. We're going to do a while loop. We're going to repeat until. Okay, or we could wait until. We're going to try the wait until, and then we're going to drop it right here. We're going to wait until the gyro sensor, and we're going to get the heading, and we're going to wait until the gyro heading is greater than, and we want to turn to the right, which means we're going to go up in degrees. So we're going to wait, no, it's a repeat until, not a wait until. Sorry about that. Repeat until, gyro sensor, and we're going to get the gyro heading. I'm going to say it's greater than, and we're going to do 87. So we want it to turn right 90 degrees, and so I need to just cut that out. So I want it to wait until it's greater than 87 because it's a plus or minus 3 degrees. And we're going to fine tune it, see how close we can get it. We're going to use a little protractor to figure that out. And so until it is, we're going to turn right just a little bit. So we're going to turn right. And this, I guess we should probably do degrees. And turn right. Now, this first number is how many degrees we want to turn right. Now, this is not heading of degrees. This is motor rotation of degrees. And we're going to just turn right. Let's try, we'll see what happens with 45 degrees. Just to be safe, we're going to power this down a little bit. So we're going to make that a 30% power. Okay. And then, okay, so here's our code in Graphical. And so what I want to do is go ahead and save my changes. And I want to show you what this looks like in standard code so you can see the difference. So take a mental picture, look at this, and then I'm going to go to View, and I want to go where I want to convert graphical file to text. So I click on it. This is the text file. And you see how we have these comments. And the reason why we're doing this is I want to show you a couple things that I would like to do with this program. I would like to comment out the driving, this driving forward. So I'm going to put just a 2/ there. And that's commenting out a command. So now what I want to do is wait until we touch, right? And then we reset the gyro. And then we turn right 90 degrees. Repeat until get gyro heading is greater than 86. You're going to turn right, power the motor, 45 degree of a rotation around. So that would be 360 divided by 45 would be 8. So 8 turns is about 8 some inches. So we'll fiddle around with this and see if this works. Okay, so we're going to go ahead. I'm going to do a file save as just so you can see it as a separate one. Notice this now says this. I'm going to change this date, and it is now 118. So I'm going to add that here, and I'm going to save this in this code. And now let's upload it and test it out. Okay, so this is the window where I'm going to upload it. You'll see Maze Challenge Phase 2. This is in C. So we need to open that up. We're going to open it up in Robot C, which let's do that real quick. We're going to do it in here. So what I want to do is open that folder. I'm going to drag this over here to open it in Robot C. And there we have it open. And so let's go take a look, and let's try downloading this to the robot. So here we go. I'm going to do one little thing. I'm going to do a file save as, and I'm going to give it Maze 2.0 challenge phase. Save it as .c. And now I'm going to compile it, make sure that's okay. Don't see any errors. Robot. I'm going to start, stop, close. I'm going to bring it over to my little screen, and let's see if it works. Okay, so here's the robot. It's set up. I'm going to go ahead and press start. Now, it's technically running, so what I can do is once it's running, I can kind of set it up exactly where I want it. And we have it at 0 degrees. It's a little bit hard for you to see the angle we're at, so I'm going to try to change it in a way that you can sort of see that a little better. Whoa, without this falling off. Okay. And a little bit harder for you to see. Maybe we'll just go back to where we had it before. And so I have it on the paper. I'm going to go ahead and press start. And, okay, each turn it was a little too much. So we're going to have to dial that back. First thing I do is I turn right 10 degrees. I'm going to save my changes. And then I'm going to go re-upload that and see how that works. Okay, I've added a little twist, and that's a repeat until the gyro sensor heading is greater than 86. And then, actually, I think 87 is what we were doing before, so I'm going to put 87 here. And then now, if it's less than 65, from 0 to 65, it turns right at 10 degrees, 20% power. And then if not, which means once we're over 65, so we're 66 up to 87, then we only go 2 degrees, 10% power. So it's going to significantly slow down. We're going to save this and see if we can get it more accurate here. I'd love to be able to say it's 90, but I think we're going to have to just go with an 87. We'll test that out, and we'll see how that works. Okay, so there's a couple last steps I want to do. I want to test it on the course. So I'm going to uncomment that forward. So we put it back in. So, and the other thing I'm going to do is break this out a little bit. So there's a little bit of time in between each of these tasks. So this is what it's going to look like as of now in Robot C non-graphical. Okay, so you can take a look at that and compare it. And in a bit, I'll show you what that looks like using the graphical Robot C. But in the meantime, let's go ahead and upload this, and we'll try it on the course. Program ready to run, and we're here on the course. I'm going to go ahead and press start. Make sure it's all lined up. I'm going to press that button, and here we go. Guess what? 17 inches, not far enough. Turn right. Looks like I overshot it just a little bit. But let's do a couple measurements. Okay, so I added if you notice there's 17 inches on there. Let's run it one more time just to double check. I'll move it a little bit more to the right. Part of the problem, I think, is where I have this set. Because I had to have it entirely behind. Yeah, so notice that 17 inches. We're going to want to increase that distance more. So instead of 17, I think we're going to want to go about 20 inches. Now, in order to do this, I'm going to write a separate program to do some calculations for us. Well, things are looking a little up, and in my next video, what I'm going to do is take a look at adding some improvements to the code itself and testing that out. We're going to try writing some functions to handle both distance and to handle the turns. So stay tuned for that video.